This meeting is being recorded.
Okay, guys, let's start. So in yesterday class, we discussed about the quality of service and how we can achieve the QoS and some security fundamentals. Can someone summarize yesterday class? Anyone?
Hey, sir, can I do it?
Yes, please go ahead.
Yeah. So yesterday we have mainly read about QoS, quality of service. And quality of service, yeah, it is also called as PHB, per hop basis. It has classification, marking, queuing, congestion, polishing, and shaping.
Okay.
And yeah, we've even learned about some fundamentals of security and classification of some traffics.
Okay. Got it.
Yeah.
Thank you.
Should,
Okay.
should I go? Should I go into individual things, sir?
Yeah, if you can elaborate, that would be good, please.
Yeah. So, yeah. Okay. Okay. Classification. In classification means we can classify different traffic in specific groups. So it is called like if you see different packets are classified based on the traffic and the condition.
Okay.
Conditions like IP address, port numbers, and applications.
Okay.
And yeah, when we come to marking, we can set a tag value to identify the packets.
Okay.
And queuing is basically a priority. So like it is like as you told yesterday, if like while we're going in the road, if like number one goes first, and like sending people based on the priority, sending packets and scheduling them based on the priorities called as queuing.
Okay, I'll let you stop there. We'll pass on this to maybe Kanishk. Can you continue on congestion? What is congestion?
Yes, like it's nothing but like when network becomes traffic. So when there is no enough bandwidth to handle the data, then the high priority packets like UDP will be given priority over TCP packets. That is known as congestion.
Okay, congestion is nothing but having the traffic that is like over than what our network can handle. So that is called congestion. It's like having a high traffic volumes at a given period of time. And we do like prioritization based on protocol like UDP versus TCP or IP address or application, stuff like that. That is correct. Dilip, can you tell me what is policing?
Professor?
Policing, yes.
Like applying to a specific traffic, it related to the some security fundamentals.
Are you sure?
Yeah. And it will monitor the traffic, the network traffic, based on the specific condition for the packet.
Yeah, so it will basically monitor the network traffic, and based on the traffic rate, it will set the limit, right? So that is the policy. It's not a security fundamental. It's more of like a quality of service concept only. So it's basically will monitor the network and make sure that the packet, it will discard the packet based on the speed limit or the rate limit, right? That's
Yeah, yeah.
important.
I just confused it with the policy map and the policy. So that's why I just answered the both.
Okay, got it. That's fine.
Mm.
Okay, Shiva, can you tell me what is shaping?
Yeah, so shaping is basically controlling the rate of transmission of the packets or traffic instead of discarding them, unlike in policing where we discard the packets.
Yeah, yeah, we discard them, but in this case, we don't discard them, but it will make sure that we will be controlling them. So we will do like pause and go, right? So that's what we do in the
Mhm.
ship. Okay, yeah, that is correct. Okay, the next topic we discussed is about the security fundamentals. We discussed about threats, vulnerabilities, exploits, and mitigation techniques. Hari Prasad, can you tell me what is a threat and what is a vulnerability?
Threat is like whatever the device is not having protection, that is directly mean like it did not have any security or any code to control from the threat.
Yeah, threat is like the likelihood of being attacked, right? So there might be
And-
someone in outside of our organization or
Yeah,
some of our domain, they might attack us. That is the threat. Vulnerability is nothing but the weakness that they might break our system. So our system is weak, so they might get into our system by breaking the password or breaking the protection that we have. That is the weakness. Exploit means that the person who is outside the
Password.
company is actually attacking us, like exploiting our system, right? That is an exploit. And mitigation techniques are like how we can improve our security measures, or how can we mitigate that attack, or how can we mitigate that threat. Those are the mitigation techniques. And we talked about user awareness training and physical access control. We talked about having better security posture, better security awareness to the users and the employees, and how we can protect our data by separating them with firewalls, IPS, and having a better control, right? And that's what we talked about yesterday. Now, focusing on today class, we will be talking about configuring devices with local passwords, and also having the security policy elements like management or multi-factor authentication, certificates, and biometrics. We'll talk about that, and also we'll talk about IPsec, remote access VPNs, and also site-to-site VPN tunnels. If time permits, we will go to the ACLs. If not, that will be tomorrow topic. But now let's start with configuring a device with the local password. So let's start. Thank you guys for answering all the questions from yesterday class. I really appreciate that. So in today, we will discuss about configuring devices using local passwords. So just like when I log into a device, it will ask me my username and password to log in, right? So that is configuring the local password. Instead of we having the password somewhere else, we configure that password locally on the box. For example, if this is a switch, switch A, and if there is a person, and if that person want to log into the switch, he will enter his username and password. Let's say the username is Hari, and password will be 3123. So that username and password will be configured on the switch. So whenever Hari tries to log in to this device, the username will be matched and the password will be verified with the switch database. If he enters the right password, we will let him log into the switch. To configure that, but before seeing the configuration, let's talk about the other component, the privilege level. So after logging in, what else I can do? Can I do like configuration, or can I do just like read only, or can I do like super admin, like reboot the devices, or can I do like any CPU level configuration? So there is certain privileges, right? So for example, let's take a real-time example, right? Let's say there is a house. Let's say there is a user. Say the user is Hari. Okay. And that user Hari is trying to enter into the house. So he should be having a key, right? House key. And that is like password. In our methodology, we will map the house key to the password. But after entering into the house, let's say there is room 1 and room 2, room 3 and room 4. On the room 3 or room 2, whatever it is, let's say there is a locker. So there will be again the locker key inside, right? So if we want Hari to access this locker, we should be giving privilege level of Hari to use the locker. If not, he is just a user who can access the other rooms, but not this room. So even though if I log into the switch, I can have certain privileges. Can I do only read only? Or can I do read and write? Or can I do only, read, write? Certain things, not all of them, like interfaces or, OSPF or EIGRP. I can do that, but I cannot do something like a CPU or CPU change, or I cannot do like restart. Cannot do. So there are certain privilege levels. So we can also set this privilege levels for each user. So for this Hari user, we can also set some privilege levels, that what I can do, what Hari can do on that box. And the next thing is encryption. So let's say there is another user. Let's say this user is maybe Kanishk. So if Kanishk logged into the box to the switch, he should not be able to see the Hari password, right? So he should be able to log into the switch. He should not be able to see the Hari password. For that, we will encrypt the password on the switch, so that only Hari, if he knows the password, can decrypt the traffic. If not, no other user can see the switch, even though see the password, even though it's locally configured on the switch. Only that person can decrypt it, but not the others. So we will do service encryption. So encrypting the password. So only user that possess password can decrypt it. No other user can decrypt it. Okay. We can also set password length. For example, when you log into the Facebook or when you go to any public sites, it might give you a few instructions like, it should contain one uppercase, one lowercase, one what else, number, and one special character like asterisk, like at the rate or dollar, like that, right? And then it might ask you like length should be minimum 10 characters or minimum 10 characters, right? Like that. So you can also set these conditions. So when Hari tries to set up a password, he should be having these conditions to be met. I think you might have already saw that, right? So Based on that, you can, you can do some minimum length and minimum requirements. And when I log into the device, if Hari logs into the device or if Kanishk logs into the device, he should be getting a banner message. Right? So like, do not log into the device if you are not intending to log in. It's just like having a banner to your switch. So let's look into the real time, right? So let's do a real time check on that. Let me show you how does a banner look like. Let me start share. Okay, so here, if I go to a terminal, you see here is my username. I wanted to log into, let me go to the channel. Okay. So now I wanted to log into a switch. Okay, so I'm going to define my username at the rate switch name. Okay, I'm logging to a switch. You see, there's a warning. This is a private interest computer system. This computer system is provided for processing of private information only. Use of this system is restricted to the authorized users. So this is called banner. So we can, as administrator, we can develop a banner so that no other person will log into the device and he has to follow the requirements. And now I am entering my password here. See, now I'm in the system already. So because I entered the password, I was able to log in. Let's say if I enter the wrong password. Okay, let's say I'm going to enter the wrong password. See, it's asking me to enter my password again because it's matching the database and it's not matching. It's asking me to enter my password again. If I enter the password multiple times, it will automatically log out my, it will automatically lock my password because I entered my password many times wrong. Okay, so I'm going to share that. So we were talking about the banner, right? So in the banner, so we will put a message. Banner is nothing but message to indicate banner is nothing but to educate or inform the user about the login warnings. So that's what we can use the banner for. So that is about creating the password, local username password, setting up the privilege level, and then doing the password encryption, putting the security minimum requirements, and then setting up the banner. Those are the basic things that we have to keep in mind when we are doing the configuration. So now let's look at how we can do all of this in the real time, how we can configure this. Now let's look into that. Any questions before I move to the configuration part?
No, sir.
Okay. Let's start looking into the configuration. So obviously I have to log into this. I have to go to switch and then go to config terminal, right? I have to go to the config mode and then define username. I have to define the username. Let's say I have to define Hari. And then I have to define password. And then define password. Password can be anything. For example, I love CCNA 123 and something like that. That can be the password. And if I wanted to do the privilege level for the user Hari, I can do like privilege level So 15 is the highest privilege level. Let's talk about the privilege levels. So 15 will be the cannot write. Now I can type. So Cisco privilege levels. Ranges from 0 to, it's better to write 0 to 15. So 15 being what? Super user or admin or full access. That means Hari can do anything on the system. He can reboot, he can upgrade, he can configure, he can clear the configuration. So if I do 15, he can do that. If I do 0, lowest level, he can do 5 commands, only 5. Hari can do only 5 things. One, he can do enable, he can do disable, he can do exit from the switch, he can do, what else he can do? He can log out. What else he can do? He can do also help command to understand if he wants to learn about the switch, he can do help. So if I do lowest level, he can do only these things. Exit is like exiting from the interface or exiting from the specific configuration, but logout is completely logging out of the system. He can do all of this. But if I do like privilege level 1, he can do like read only. Like he can look into the configuration, but he cannot do much things. He can do just read only configuration plus whatever the above 5 things he can do, like at the 0. So on and so forth, there are different levels. So in this case, I'm defining 15. Okay. So that means I'm giving super admin level access. Okay. And then after that, I'm giving that to a user name Hari. That way, I know that Hari is mapped with the super user. He is the administrator and he's the he can do anything on the system. The next thing is to encrypt the password, right? So I can do service password encryption. If I do this command, all passwords will be encrypted. Meaning no other person can see Hari's password. Hari's password will be automatically grayed out. It's not human readable format. Let me show you that how it will look like so that you will get an idea. Again, stop share. Here, if I do show running configuration, you see there is a username admin, and if you see the password, this is not human readable format. It is all encrypted. Why it is encrypted? Because if I do show running configuration, if I do service, oh, this version is automatically encrypted. Maybe let me see. Hold on. Yeah, this is being an access box. It is automatically encrypted in them, but if it's an iOS box, you have to use this command. Let me stop share. So I have to use this command to make sure that the password will be encrypted. Okay. Next thing is to create the security length. For example, I can do like security I can do password, and then I can do minimum, I think minimum length. And I can define the length, maybe like, let's say I wanted to put 10 characters. So the password, we can limit that to 10 characters. We can put minimum length should be 10. And also if I wanted to define banner, I can do banner and then define login. Then I can enter my message. Whatever message that I want to say, like you can say like, I wanted to protect my switch. Please don't log in if you are not supposed to. Something like that. You can put the banner there so that you will able to. And yeah, that's how we do the username configuration, privilege level, encrypting the password, setting up the minimum password length, and then setting up the banner. Any questions?
No.
One question. Hari.
Yes, go ahead.
So here the network administrator will be knowing the username and password of all the users, right?
No, he cannot. Even if I'm an administrator, I cannot know the password because it is encrypted, and I cannot decrypt the password even though I'm an administrator. Because it is MD5 with key level 5. So I cannot decrypt the password unless until I have the private key to decrypt that. So it is not something that is easily broken. Like we cannot retrieve that. So it has to be carefully in there when we encrypt the password. So at least we have to have a database. If I'm putting an admin username password on the machine, I have to make sure I keep it safely. Otherwise, I cannot decrypt it back.
Okay.
The reason is, let's say there are 5 users, and you being an administrator of the switch, if you know their password, you can misuse that. So no one should know that password unless the user who we are building with, right? So that's why we use something called Active Directory, where we will not use the local database on the switch. So let's say
But like how the user get to know his password?
what do you mean? The user, who is the user here? So let's talk about that, right? So hold on. So in this case, okay, so Hari is there. Hari is able to put the, he was able to log in with the he was able to go to the console, and he was able to put the username password on the switch. He configured his username and password. If administrator logged into the switch, he cannot see the Hari password. Okay, but if administrator is the one who is configuring Hari username and password, then he will know it. Okay, is that clear?
Yes.
So to avoid this, we will never configure the username passwords on a switch. We will just put the admin username. Only admin will put the admin username and password, but Hari will never put his username and password on the switch, because he has to ask the administrator to put the username and password, right? He cannot directly log into the switch and put it there. He has no right to do that. So that's why we use a concept called Active Directory. Active Directory, AD. So what is that does is, Hari will locally log in with username and password on this laptop, right? So Hari will have a local username password on the laptop. The laptop username password will be synced with the AD. If he wants to log into the switch will talk to the AD and matches the username password of the Hari. If he enters the right password on the switch will send it to AD. AD says, okay, he entered the right password that's on the local machine. You can allow the access to the switch, and the switch will automatically log in him. This is called AAA. Authentication, authorization, accounting. So authentication means whether Hari is able to log into the device or not will be checked with the Hari password on the AD. That is authentication. Authorization means once Hari logged in, what level we can give the access? Can he do privilege level 1, privilege level 2, privilege level 5, 10, 15? That can be decided by the authorization. And accounting means what did Hari do after logging into the switch? Did he shut down the interface? Did he turn on the BGP? So that is about accounting. So in the real case scenario, let's say there is a stadium. Okay. Let's talk about IPL match. Okay. Now let's say Hari want to go to IPL. Okay. So to go to enter into the stadium, he has to have a ticket with him. Ticket. So first thing is ticket. So what? So that is authentication. So at the gate, they will see the Hari ticket, right? They will see whether Hari has a ticket to enter into the system or not, into the stadium or not. That is the authentication part. Next is authorization. Meaning where he can sit in the stadium, where he can sit. Whether he can sit in the front row, or whether he can sit in the back row, or whether he can sit at the middle row. There are different rows, right? If you pay more, you will be sitting close to the match, right? Or the stadium at the front line or middle lane. There are different viewpoints in the stadium, right? So that is different by your authorization. And last thing is accounting. Accounting means how much time Hari stayed in ground. Did he supported CSK or GT? Whatever the team, right? Did he supported the right team, team A or team B? Or did he supported, or did he buy popcorn? So what did Hari do in the stadium? That is all accounting. So authentication means whether he is able to enter into the stadium or not. Authorization means where he can sit in the stadium. Accounting means what did he actually do on the stadium? Whether he watched the match or did he followed something else in the match, or what did he do in the stadium? Did he bought popcorn, or what did he do while entering the stadium? That's what this concept, right? Similarly, same applies here on the switch. Whether the Hari can log into the switch, that is authentication. Whether Hari can do what level he can do, that is authorization. And what did Hari actually do? Like, did he enter the show run command? Did he shut down interface? Did he configure BGP, OSPF? That is all accounting. Any questions there? So the reason why I did not explain this concept is this is not part of CCNA. This is part of CCNP. That's why I did not told this concept. But because you asked the question, I had to explain this.
Yeah, understood. Thank you.
Okay. Any questions before we move on? No questions? Can I go ahead?
Yes, sir.
Okay. So the next topic is we wanted to do the other alternatives, right? We know that having this level of security is not that secure. So having a username and password is not only the right criteria, right? That's why we came up with AD. We talked about having an AD. It is Active Directory, right? So instead of we relying on local database of the switch, we will configure the username and password on the AD, where the user, when he bought a corporate laptop, he enters his username password on the laptop. That username password will be synced in the AD, and that AD will be talking to the switch. Right. So that way, an administrator does not need to know the Hari password. It is locally stored in the AD. When you enter the password, it uses a protocol called LDAP. You don't have to worry about LDAP. It is concept on Windows administration side or server administration side. This is not an network engineer concept. It is a system engineer concept. You don't have to worry about that. But this is the protocol to talk between your laptop to the AD. Okay, so that's the protocol they use there. So that is one security measure we can do to make sure that we are protecting the Hari password, right?
Excuse me. With the AD, like where exactly is it located? Is it a physical location in within a laptop, or is it between the laptop and the switch, or where exactly is it supposed to be?
It can be anywhere in the company. It's a server. Basically, it's a Linux box.
Oh, okay.
It is nothing but a server. It can be a Windows server or it can be a Linux server. It is basically a beefy box that is storing all of the username and passwords. Usually they put the AD server in internal zones, like for example, maybe like internal security zones where it is protected with a firewall.
Okay, thank you.
So that's why we thought, that's why the security folks thought we have to do multi-factor authentication. I think you are, by this time you already know what is multi-factor authentication. Something like OTP. When you enter your bank credentials, you will get a 6-digit or 5-digit code to your phone. That way they know that you are the one who is accessing your bank, right? I think you might have already seen. Sometimes they might call you. Sometimes they might send you a text message making sure that you are the person who is logging to the system, right? So let's say Hari is trying to log into Bank of America now, okay? He's trying to log into Bank of America site. So he will log into the system. He will put his username, password, and then this password will be looked into the Bank of America AD, right? So once he enters the right password, the Bank of America's AD will talk to the authenticator. In this case, a token service. This can be an Okta, or it could be Duo. These are all company names, right? So that will generate a code for Hari, and that code will be sent to Hari's phone. Hari keeps his phone in his pocket, right? So he will open that, he will enter that password here. So this matches with this. So then he was able to access his account. So instead of having one stream of username password, we added one more multi-factor authentication. Here, the two factors are who is Hari, what Hari have, right? So he has a phone. And who is Hari is defined by username password. right? So now let's take a different use case. Now Hari wants to open his phone. Okay. So there are two factors here. Either he can enter his password, like security key or the PIN code, or he can do facial recognition, or he can do biometrics, like handprint, like fingerprint. So this is also two factor. One is who is Hari. That is with the passcode, or sorry, what is PIN code? The other one is something that is unique to Hari, which is his facial recognition, right? So we are doing two factor here also. So maybe I can know the Hari passcode, but I cannot know Hari's thumbprint. I cannot replicate that, right? Or I cannot do the facial recognition of Hari. Sometimes, if this fails, you can have this as backup, right? I think some phones do it, but at the corporate systems, it has to pass both. Hari has to enter the passcode and PIN code also. He has to verify that his identity. Otherwise, he cannot get into the system. And something is like tokens. For example, Hari has a laptop and he's trying to log into the system. Okay. One is username, password. Okay. And the other is certificate. So what is the certificate means? Hari should be having a certificate on his laptop that will be verified by a certificate server, which is called PKI, public key infrastructure. So Hari should be knowing the username and password, and Hari should be installing a certificate on his machine. That way, it will be validated by the PKI server, and then he will be given access. This is something you are, I mean, the username, password, and something you have, like an authenticator, right? Like your certificate. So this is also a two-factor authentication. So this is all adding multi-layers of security to your systems. So similarly, the switching concept, if I, as an administrator, if I wanted to log into the switch, one is AD plus PIN code to your phone. So we can also enable this in the laptop. I mean, on the switch. So we can also do this kind of multi-factor authentication. This is to add better security to our systems. There are other recognitions like voice recognition, palm reader, retina scanner, fingerprint reader. We talked about that. Facial recognition. We talked about that, right? So these are all the other scans already there. Any questions there? Yeah, it's all basic. Now let's move on to the other concept, which is protocol called 802.1x. This is called network access control. This is important. The reason why I said important is like it is something that is used in many corporate networks to restrict the users. And it is important to know, not in terms of CCNA, but as an engineer, it is important to know this concept, network access control. So let's say Anurag is there now, okay? So Anurag wants to log into the corporate device, okay? like a laptop and he wanted to access what he wanted to access. He wanted to access like an corporate Wi-Fi. Okay. So Anurag wants to log into the system like his laptop, and he wanted to, it's a company laptop. Okay. Let's say he's working in a company called, maybe let's say he's working at Dell. Okay. Now Anurag got a laptop from Dell. The company gave him a laptop and he opened the laptop in the office and he wanted to connect to the Wi-Fi. That is the end-to-end goal here. So that's the goal. So here in this case, Anurag first has to log into the laptop. So Anurag should know username and password. Okay. And once he logged into the laptop, he should be connecting to the SSID. Right? He will click on the Wi-Fi button and he can able to connect to the SSID with the SSID password. Right? SSID is nothing but the Wi-Fi username, right? The Wi-Fi name is nothing but SSID. Right? And he has to enter the password for the Wi-Fi. So it is secured in two ways. One is Anurag knowing the company laptop username password, and Anurag is able to log into the corporate Wi-Fi with the Wi-Fi username and password. But there is a glitch to it. What is a glitch means? Anurag can bring his own laptop. He can log in with his, let's say he owns Chromebook. Okay. He can bring his Chromebook to the company network. He can connect with the username password that is local to the machine, and he can still log the SSID with the SSID username password. So he is jeopardizing the company laptop and he is bringing his own machine. That is called BIOD, bring your own device, BIOD. Is it secure? No, it is not, because we are not supposed to bring our own machines to the corporate network and log into our corporate Wi-Fi's. It is not feasible. So what we can do is, we will put a multi-factor authentication with a certificate. So once we send the laptop to Anurag, we will put a certificate here on his machine. So once we give the laptop to Anurag, he has to log into the machine. At the same time, this machine should have a certificate. That certificate should be validated by the corporate PKI server. So now, even though Anurag brings his Chromebook, that certificate will be missing on his machine. He cannot download this certificate and he cannot put that back in his machine because we will put the role-based access. But Anurag cannot download the certificate and he cannot replicate that to the Chromebook. That's how we are protecting our corporate Wi-Fi. Only the machines that have certificate and the username passwords will be able to connect to our Wi-Fi. Any questions there? No questions? Is it clear? Okay. So now let's talk about the workflow of the .1x. This whole process is called certificate. Using certificate and username password is called .1x. This is called network access control. Okay. There is a lot of granularity in it. For example, there is like protected EAP fast, EAP TLS, EAP TLS. There are different protocols in it, but that is concept again at the CCNP level, at CCNP security, not in this training. So we don't have to worry about all of that now, but understand the concept of network access control and what is .1x. Okay. Now let's talk about the three important concepts in it. One is supplicant. One is authenticator. One is authentication server. So in this case, Anurag, laptop, switch or router, or SSID or WLC, and then authentication server. So this is Anurag machine or laptop, right? This is like SSID, like a router, right? Where the Wi-Fi is hosted, like Wi-Fi, like that. Right? So here this is called supplicant. Supplicant is the machine that is trying to connect to the network. That is the supplicant. This device is called authenticator. Authenticator. Okay, so the device that is sending that request, the actual authentication request to the server. For example, this is the authentication server, right? Maybe a PK server or AD. So that is the authentication server. So this is the supplicant. So Anurag is the end user. He is using the supplicant like his laptop to connect to the corporate network with SSID, that is authenticator, that is sending the request to the authentication server, which is allowing his access or denying the access. So this is the workflow of the .1x. This whole process is called. Any questions? No questions? Is it clear? Let's talk about the next topic, remote access and site-to-site VPNs. So remote access is where, let's say, you're sitting in Starbucks. So Sai is sitting in Starbucks, okay? Now she wants to connect to the corporate network. Let's say her office is in Chicago. Okay, and she wants to make a SSL connection to the Chicago office. Right? So that means that she is making a tunnel from Starbucks, her laptop, to the corporate network. It's a tunnel over the internet. So once Sai has internet connection of her laptop on the Starbucks Wi-Fi, from there she will be connecting to the Chicago office network and she will turn on the VPN. So she's a remote user trying to make a connection to the corporate network being on the VPN. Okay. It's just like people working from homes. They will be sitting in the home, they will be having internet connection, but they will use a thin client. For example, they can do any connect VPN, or they can do Global VPN or Pulse Secure VPN. There are different brands out there. They can use that VPN to connect to the corporate network. Why do we need the VPN, guys? Because we cannot send the traffic directly on the internet. Internet is not secure. So we will form a tunnel, encrypted tunnel, meaning no one can steal our data. So Sai can send her username, password, or corporate data over the tunnel. No one can encrypt or decrypt the data, even though they capture in the middle. If you are making a WhatsApp call, it will be showing as end-to-end encrypted, meaning like no one can in the middle can decrypt your phone call and they cannot replay it, right? It's all data, right? So let's say you are making a phone call to your family and it is confidential with you and your family, right? You don't want someone in the middle to see what you're talking. That's why we use encryption, right? Similarly here, She wants to log into her corporate network, she will turn on the SSL VPN, and that way she is able to join the corporate network. But her laptop need to have a thin client, meaning she has to need a software, she has to open the software, and she has to connect to the corporate IP address. That will form the tunnel for her. That is called remote SSL VPN. Okay, now let's talk about site-to-site VPN. Any questions before I move on from this topic? Remote SSL VPN. Okay, we'll talk about site-to-site VPN. The name itself says it's a site-to-site, meaning, let's say there is a corporate office and there's a headquarters. There are like 10 employees. Let's take this is a CVS store. Okay, this is a CVS store, and there are 2 registers in the CVS store. Okay, CVS pharmacy store, and this is a CVS office. CVS office is in Connecticut, right? And this pharmacy is in, let's say, it's in Texas. Okay, so now there has to be a corporate tunnel between these registers in the store. They have to connect to the corporate network, right? Otherwise, let's say a individual came and bought something in the store and paid the bill, and the transaction has to go to the store or the data center, right? So that communication will be broken, right? So there should be a site-to-site tunnel between the store to the corporate network. This is called site-to-site VPN. Meaning, if you have a branch location or a branch site, and you want to connect your branch site to a corporate data center or your office space, then you will have a site-to-site tunnel. But if you're a single user and you wanted to connect to your corporate network, you will use a remote SSL VPN. That is for single users. Do you guys understand the difference there? Yes, no.
Yes, sir.
Okay. So let's talk
So in
about
the site-to-site VPN, we cannot connect our personal laptops, right, sir?
if your personal laptop has a thin client, meaning if you have a software and that software is allowing you to log into the corporate network, then you can use it. But you should be having the username password to log into your company, and also you should be having a certificate.
Okay, got it.
That's why some companies, they will let you work on your laptop directly, but they'll install a Citrix or Palo Alto device on your laptop. It's a small software.
Okay, thank you.
It all depends on how much security you want, right? Okay, so now let's talk about configuring the VPNs. I don't know how much time we have. Give me 1 second. Okay. Yeah, I think we don't have enough time to look into the configuration. Okay, let's stop there. Let's do one quick summary of today's class, and we can look into the configuration on how we can do it, and like what is phase 1, phase 2. I think we can continue that tomorrow. Let me quickly take a look on that. We already covered DHCP snooping, but we did not cover ARP inspection. We covered authentication, authorization, accounting on a high level, right? Okay. We talked about, okay, all right, yeah, that's fine. So we'll stop there. So in today's class, we discussed about configuring local username passwords on the database. We discussed about AAA, like authentication, authorization, and accounting of the user. We discussed about security, multi-factor authentications. For example, we discussed about certificate-based authentication. We discussed about password with AD, password with biometrics, like that. We discussed various combinations there. And we discussed about site-to-site VPNs like remote SSL VPN or site-to-site VPN, right? So we discussed about that. So the main difference when we are building the remote access and the site-to-site is remote access VPNs are having one individual user logging remotely from his laptop or his machine directly logging to the corporate network. A site-to-site VPN is like building two networks connecting two office spaces with a tunnel, which will be encrypted end to end. Okay, and yeah, I think let's do a quick round. Sudhir, can you tell me what is service encryption?
Oh, what's the question, sir?
What is service encryption?
And encrypting the password, so users that possess the password can decrypt.
Yeah, so it's only completely encrypted
Decrypt.
to the password because no other user can able to see the actual password of the user, right? So it's encrypted. Only the user that he is possessing that username can log in and he can validate that by decrypting his password if he wants to. If he forgets his own password, there is no way backing out, right? Because he does not have his password, so he cannot log into the device itself. So it's like logged position. Okay. Okay. Sriram, can you tell me what is privilege level?
What's that?
What is privilege level?
Privilege level.
Yes.
It's full access to all commands. Hello.
No.
Yeah.
Any other answers?
So it's all about the Cisco has like 0 to 15. So for 0, it is just about the like read only privilege, and also like 5 other things, which is enable, the exit, logout, and help. For like that, we have from 0 to 15. If it's 15, it's like admin, where the user will have the full access, and if it's 0, it is just the like lowest level, wherein they can have only access to like 5 things.
Yeah, that is correct. So in the privilege level, we will define what level of access that can be defined for the user that they can do on the system. Thank you. Dilip, can you tell me what is Active Directory?
Do that. Not sure.
Sorry.
Yeah, I'm just thinking.
Oh, you're thinking. Okay, got it.
Sorry.
Okay, next person. Monica, can you tell me what is AD?
Yes, sir. Like it is like a Windows server or Linux servers where we used to put the passwords and where we can enable like a administrator to manage permissions and access to the networks.
Yeah, correct. So it's like a database where we store the username and passwords, and the administrator will manage it. Correct. Thank you. Let's see. Anurag, can you tell me what is authentication, authorization, and accounting?
Yeah, that's AAA. Authentication is when the user logs in. Authorization is where we give different permission levels to the user. And accounting is basically logging the user activity.
Perfect. Well done. Okay. Kanish, can you tell me what is network access control?
Yes, so it's one of the protocol. Like to avoid login into different devices in the corporate network. Like we set some protection, MFA kind of thing. Like let's say suppose the device should be like having the certificate so that that will be validated by the PKI, that is known as the public key infrastructure.
Yeah, that is correct. So it's having like a multi-factor authentication kind of thing where we will make sure that the corporate machines will have certificate and they have to be validated before we let the user log in.
Yes.
Okay.
Yeah.
That is correct.
Only the machines that has certificate will be able to connect to the Wi-Fi, corporate Wi-Fi.
That is correct. Okay. Shiva, can you tell me how do I protect my laptop to be secure? What things I can do to make sure my laptop is protected?
I mean, to protect your laptop.
In terms of login, what can I do to protect my laptop login?
Okay, so first we need to, encrypt the password.
Okay, first is to create the password and then encrypt it. Yes.
Yeah. And then protect the password from going to other users or other networks.
Yeah, that is already done with the encryption, right? So we encrypted that and we will make sure that it is secure. Okay. What else we can do? Like we will do the certificate, right? We'll make sure the certificate is also there. So I don't have to log in and I don't have to go to my public sites without a certificate, right? So it has to have certificate as well. That is one thing we can do. And the next thing we can do is like
multi-factor
authentication. So I can do like an biometrics or facial recognition. I can do like, or I can do like an Okta service, like getting a phone message or PIN code to your phone. That's a multi-factor, right? Yeah, we can do that. Okay, that's good. Okay, I think we covered pretty much. Thank you for answering all the questions. You guys did a good job. And I'll leave 4 or 5 minutes for it if you have any questions. If not, you're free to drop. Let me stop this recording.